Now I'm going to be operating these surfaces so you can see how it works. What's unique is the pitching mechanism and a little bit of the rudder. Now the rudder, as you can see over here, is working like a rudder. But you'll also notice that along with that, the propeller is yawing as well. That's because of this linkage or this mechanism here, which is a gimbaler. Here I am adjusting yaw, and here's I'm adjusting pitch, like so. As you can see, the propeller follows along, yaw and pitch. How about that? All right, so that's the mechanisms, and I don't need the system to be on for what I'm going to do next, which is to immerse it without any flotation, just so I can get an idea of where the center of buoyancy is without flotation, as well as I've already affirmed the center of gravity. I'll do that in just a moment. But I'm going to turn the system off. And by the way, I mentioned the lights previously. You see them there? These will go on as soon as I put the top on. But that's where the lights are, right there, just that switch. So I don't want to waste current. So the system is off. Transmitter's off. Now I'm going to put the top on. I've already put a snort induction tube in there. I'm not even going to make it up because I'm not going to use the ballast system. So I'm just going to assemble the model. The idea is to get the rudder started and then drop the hull down, make up the forward pin, which is, as you can see, the ram. I want to catch that knurled knob right there with the skip, and that secures the stern. So now we're going to put it in the water. And here's my terrible test tank right here. So it should sink like a rock. But right now, let's affirm where the center of gravity is. You know, we're not going to change the center of gravity, but we will have to adjust the center of buoyancy to be right over it and to exert enough force to cancel the gravitational force, which pulls it down. The buoyant force will push it up. And when we can get those two force lines aligned vertically and of the same magnitude, then we should be neutrally buoyant in the medium. So, without further ado, it's not terribly heavy. Not terribly heavy. But where I need to center the foam, it's right about at the... Ooh, look at this. We didn't want that to happen. Somebody's trying to make good their escape. There we are. Well, I'm going to have to address that later. But anyway, where does the center of the foam have to be? Well, I'd say just about where the salon is. Yeah, which is where the center of gravity is. Huh, not too bad. All right, I got to keep in mind that I haven't I don't have the ass end secured. I got to work out why that didn't work. You see the flood and drains, right? That's where all the water goes. Okay. Yeah, that's great. Get water right in the transmitter. All right, so without further ado, let's see what's going on. Nice thing is I can collect all of the foam around this area right here where the salon windows are. So that's where the center of buoyancy has to be longitudinally, and it has to be reasonably high, which won't be hard to do because the design waterline on this thing is so, in other words, the freeboard is very, very short. There's not much sticking above the water and surface trim. So we can put all of the foam down here. So we can put a big hunk here, and I think we'll be okay. So after an immersion like that, particularly after a test, you want to take the cylinder out and make sure everything's dry, and then take the bulkheads out and pull things out, let them air out for a while. So that's fine. Let me go rescue the skip. I gotta figure out why that didn't secure like it should. Oh well. Fun and games. Well, while I'm at it, I might as well show you the entire light array. So we'll turn on the lights, and you'll see these tabs right here. These carry current to the upper window lights, which are, of course, in the upper hall. You see them here, like so. All right, so we'll just plop this guy down. First the rudder. There we are. You see when it went down? Made contact. And we got our lights. So, all right. Well, it's time for my hideous nap, so I'll put this thing to bed for a while. If we can get a little close-ups on the gimbal mechanism here for you. Propeller. Mechanism. And even with the cylinder in the middle here, I'm going to have plenty of room on either side of the cylinder for foam. So that'll be our next operation. The initial trimming of the Nautilus starts with a trial amount of buoyant foam. It's more convenient to initially strap it to the outside of the model so that you can make changes in quantity and position easily, rather than trying to guess where it would go on the inside eventually. So this trial amount, let's see how it works in the water. Without much ceremony, it goes into the water and we let it sink, like so. All right. There was a bubble in the back. I want to make sure I get the bubble out of the hull. Okay. Well, I can position some of it forward. Now, the ballast tank in the subdriver is empty right now. So this should, if it's properly trimmed, it should float at the design waterline, and I'll bring it up here, which is right about a foot or two under a freeboard above the deck there by the skiff, and this much of the front end sticking out. Well, you can see so much of this foam is just laying out. So I'm going to shift its location lower so that foam will be beneath the design waterline. And also, clearly, it has to go forward. You see that down angle it took? Yeah. So I'm going to move it forward and move it down, but I'm going to keep this quantity. So, all right. Sometimes you hit it the first time, and then sometimes it takes literally days to play around with the thing. All right, so I'm going to go ahead, move it down, and move it forward a bit and see where we're at. Well, that's an improvement. That's a marked improvement. Now, even with that quantity of foam so far below, I still have a great deal of static stability about the roll. Damn, that gives me a free hand to put as much foam low as I need to, or wherever I can find room. So, boy, that's pretty good. I'm only I'd say a 1/4 inch away from freeboard height I want. The deck is just awash, or barely awash. Yeah, well, that's encouraging. Yeah. All right, so what I'm going to do now is start placing foam. I'm going to take this foam here, shave it as little as I can, because every time you shave it and cut it to conform to the geometry inside, you lose some buoyant material. But as a trial amount, this is quite pleasing. I didn't think I'd be this far ahead of the game with only the second wetting. And notice some of that foam is still projecting above. Well, this might actually be the correct amount. But now it's a matter of making it fit the inside without interfering with the installed cylinder or any of the mechanisms that have to be clear of obstructions on the inside. All right. Well, that is encouraging. Okay. All right, I've removed the foam, but I've kept its position longitudinally pretty much where it was, because that's where I want it to fit longitudinally. But ideally, I want to get as much of this foam on the upper hull as possible and as little as possible on the bottom. For the higher I can place the foam, the higher I can get the collective center of buoyancy in the vertical direction away from the vertical component of the center of gravity. That distance equates to the degree of static stability achieved. And even though with this hunk of foam so far below, just by necessity, it still had some reasonable degree of roll stability, but more is better in anybody's book. So I'm going to try to get as much of this foam. As you can see, there's a left and a right pile here of foam, which will be installed into the hull. Most of it, hopefully, within the upper hull. So that's the next operation. All right, so I'm going to take the upper half of the hull and move it to the workbench behind me. Of course, that means we have to take out the securing pin at the bow and slide the skiff back, releasing its little latch back here. Fine. And then we very carefully lift the upper hull off of the lower hull, like so. Okay? Now, I've got this little caddy here, or work stand, that permits me to, without damaging any of the detail here, to secure the upper hull like so. There we are. Okay. Now, since we know we're going to have a cylinder in here, and we don't want any of that foam to interfere with the cylinder, I've taken this length of 2-inch cylinder, which is suitably cut to a length which puts it halfway, puts its center line at the center line of the brake. So I worked that out earlier. So that tells me that I have this annular space. You notice how it gets tighter at the tapers, right? But I have all that annular space for foam. And again, this is the upper hull. We want the majority, as much as we can get in there. All right, I'm now trimming pieces to the correct shapes so that they'll fit within these wedge-shaped annular spaces. Now I'm using a hot glue gun. Makes the work go very quickly. And it's done as simple as this. And there you go. And then we affirm that that's going to work without interfering with our cylinder. All right. So now we have those stern pieces there. And now we're going to do stern pieces, or the bow pieces up here in a similar fashion. Put the upper hull on top of the lower hull, and it's not fitting. So what I've done is I've taken this water-soluble smear, which I usually use for weathering, but I put some tape on top of the cylinder where I thought it might be hitting, because I have an interference problem, and I just rub it in there. And I did find some areas at the forward part of the upper hull's foam, and I already ground that away. And I still had some interference problems, so I put a smear here, and put a smear here, and then I put a smear here. And lo and behold, there it is. When I put the upper hull back on, the smear left a mark there. So that's telling me that's the interference point. I'm going to come back and clobber that with with a knife and cut away that material, and hopefully we'll get a good fit. Well, after I inserted the foam and I did a test fit of the upper hull and the lower hull, I found that it was rocking. So obviously I was hitting the foam with the cylinder. I covered the cylinder with some protective masking tape, and I took some of this water-soluble smear and I put it all over that thing. And what I had done, now I've already done this, I'm just backing up so you can see the operation. After putting the smear on, I take the upper hull, lay it on the lower hull, press it down, and that leaves an imprint wherever the smear on this tape hits the foam. It leaves an indentation or a mark on the foam. Then I come back with a moto tool and I do the rough grind out on that high spot. You could put the smear directly on the cylinder, but then you're got to get a wet, damp cloth and clean it off. Why do all that when you just throw out some tape? So, but I do have some smear over here and here, but a wet rag, and that'll be gone.